One of the biggest and most commonly actions calculus has ever been known to do is finding the areas under curves and lines. But how does this exactly work? We are going to be using LRAM and RRAM approximation methods to find out how to do this. Left rectangle approximation method and right rectangle approximation method accordingly. Here's a graph with a simple parabola to start. When finding the area under a graph, things that we often think of doing is forming it into simpler shapes that we can find the area of using our geometric equations. The rectangle approximation methods, of course, use rectangles, and this one right here is LRAM. LRAM means that the rectangle's leftmost point is going to be on the graph. Well, the rectangle's rightmost point will be on the graph on the right rectangle approximation method. LRAM for a parabola underestimates the area, while RRAM will overestimate the area. But what happens as we make these rectangles thinner? Well, as you make them thinner, they're going to be closer and closer to the graph, meaning that they are more accurate as an approximation of the curve. So, as you make them infinitely thin, this means that we can get a perfectly accurate approximation of the curve, meaning that as we make them thinner and thinner, we will be able to get the area that we are ultimately looking for. And this is what integration is all about.